Discovering Neo4j Aura free with Lju and Alexander is today's topic. And going over the plan a little bit is what's happening. So I guess if you're regular, you know what's coming. But if you're not, then a quick recap. We want to go into what Neo4j Aura free is, what it actually means to work on Neo4j Aura free. We're going to pick a data set. Honestly, I don't know what data set. What data set do we have, Lou?
So we have, so it's an interesting one. Let me bring up the, 2 seconds. So I'm going to drop a link in the chat. So there's Cristina Escalante, who we work a lot with. I can't send a message in the chat, so I'm going to have to pop it in our private chat, and Alex is going to pass it over. Sorry, I'm still getting set up. I do apologise about this.
No worries.
So there's this music data, so it's resonate.is, and so from what I understand about it, it's one of these streaming services where it's sort of equitable funding, so when you buy songs, it's a bit fairer with money and what Christina has done is she's put together some examples in and we're going to be using some APIs. So this is going to be a voyage of discovery for all of us working with this data. So this is truly new. I had a very quick peek at it last week, but effectively what we've got in here, we've got song tags and titles and that kind of thing. So what we're going to do is we're going to be having a play with that, having a look, see if we can do some cool things with it. I could very easily see us doing quite a few episodes with this data set. It is a fun data set. But what this does, certainly as a first episode, it gives us an opportunity to have a look at how we can work with some open APIs. So whereas previously what we've been doing, we've been using load CSV to get data in, this week we're going to be loading in some JSON data. Ooh. So yes, we're going to be doing something different today. So it's exciting. Yes, so this is a great example of being able to see how we can really quickly get up and running with Aura, how we can pull some data in, how we can start querying it, and it doesn't always have to be load CSV. We can use other things too. So that's what we're going to be doing today.
That's cool. That sounds exciting. I'm looking forward to that. If you have any other data sets you'd like us to explore, we will continue doing this series until early September. So we have another few sessions to go. So until that, you still have time to send us your data sets. If you have anything you want us to look at, please don't be shy. Ideally, it should be a CSV or not a bit. We're going to do JSON as well. Maybe it could be a JSON as well, but it should be publicly available. So yes. If we have to register somewhere and get it somewhere, then it's not the goal of this session. But if it's somewhere on our repository available for everybody to access, then just ping us that, and we can look into it. Yeah, so we're gonna pick that data set. So today it's gonna be music. So that's a good topic. I think everybody can get around that. We will then start a little modeling exercise, where we go, what questions we might ask to the data set, what kind of queries we want to run, where do we want to explore this, in which direction we want to go. So this is the plan for today. Determine the data model, of course, and then see where we land, and then obviously load and query, get the data into Neo4j Aura, run some queries, and you will see how quick and how easy it is to get from basically a table to a graph with Aura free within. We have started the stream basically now, and by the end of the hour we will have it. So in the remaining 50 minutes or so. What is Neo4j Aura? Just quickly. Sorry. Yes, Lou?
Yes, I was agreeing with you.
Something?
None? I was
okay,
agreeing.
Good. Quickly, maybe I want to give you a rundown on what Neo4j Aura free is. So it's on the right-hand side. You see a screenshot of it. It is a Neo4j database as a service in the cloud. It's managed. It's a managed service with elasticity. So depending on what your demands are and what your requirements are, you can scale it up and down. Obviously, Aura free basically is a limited first step, and then if you then decide to go further with professional or even further than that, you can scale it up and down. And Aura basically will do lots of things for you. That means it's fairly easy for you to maintain that. So it's kept up to date, so you don't have to worry about updates about recent versions, recent bug fixes and the like. It's managing your backups for you, so you also have to worry about that. It's providing a continuous uptime, so that means it's always on, basically. And monitoring is overseen as well. And all of that is available on that link. So either if you're watching on Twitch, you can just type !Aura, and then that link will come. Otherwise, you need to type that in dev.neo4j.com/aura, and then you have a page where you can then register for Aura. You can find more information, what it's all about, and so forth. So I hope you will all do that, and especially now, if you want to run along with us today, you can also do that now. Go on that page, start your Neo4j Aura free instance, and then continue doing what we do in this session today. Anything you wanted to add, Lju?
No, sounds fantastic so far.
Cool. So then a little overview what Neo4j Aura Free is. Neo4j Aura Free is the free, obviously, the free version of Neo4j Aura. How often can you say Neo4j Aura in 2 sentences? So you have a limited edition that gives you 50,000 nodes and 175,000 relationships. So that's fairly good project size for a test run and for a development of a first project. You get access to Neo4j Bloom and browser, so these tools are available for you. It's going to be free forever, so it's not going to close. So compare it to Sandbox. Maybe Sandbox closes after 7 days maximum. This will stay free forever and be kept with you forever. And all you need to do is go on that landing page I just mentioned before, and then you're ready to go.
This is what we're doing today. So we are going to be looking at the Resonate data. So I was talking about, Christina has put this together. So this is something she's looking at. So I think we're probably going to be doing a few of these, and I will try and organize a plug for this because there's a nice piece of work that she's doing. She's building out an entire application built off the back of this. So this week, what we're going to do is going to be looking at the data that she's using to pull all of this together. So you've got the link there. Don't worry, we'll have the links in the YouTube video that follows after, so I will update that later on in the day, so you'll have all of that information available to you. So let's get going and have a look at the data. So I'm just going to quickly pop the link in the chat. So Sergio's joining us from Spain, and Shabana is joining us. Hello, thank you for joining us.
Welcome. Hello.
I know, very cool. So this is the repo. So I've popped the link in the chat, and so you've got the links here, so you can see you've got some information about that Christina is building. So you've got some information about setting this up. So I'm not going to do any of this stuff. We're not going to be running this stuff. I am literally just interested in this bit of information. So let's have a peek at the links here. So this is the Resonate page. So this is the community-owned music network.
Lju,
So
your microphone is a little bit, it's creating some noise. Maybe, I don't know, maybe are you touching it, maybe?
Oh, I'll move my hand out of the way.
I think that's better. Yes, thank you. Although now I can't hear you anymore. Oh, no, you're back. No, you're back.
Sorry, I couldn't get anything working today. Makes it exciting.
That's all right.
So this,
exactly. It's a blood pressure up.
Oh, I know. So this is the Resonate website. So you can find all the information about that. And yeah, so you got this. Basically, you got the different services. It's showing the thing. I think this allows people to go on as well and share their music and everything. So this is the Resonate website, and they've got a bunch of APIs available as well. Hello, Anu. Thank you for joining us. And yeah, so this is the repo, so all the API things. So you've got the links embedded within Christina's GitHub page, so you can see all the information there about how you can look at the information. And the other thing as well, it might be my dodgy internet because I'm tethered to my phone because I was connected to my laptop. You know what? Let me just quickly switch my network just in case to make things a bit better. So 2 seconds. Oh, I can't change my network. I will give it 2 seconds. Hopefully we'll have a better network and then we'll be in business.
All right, cool. Let's see what that.
Whilst it attempts to connect to the better Wi-Fi in the office. So yeah, so basically this is what Christina's put together, and the bit that I'm really interested in is this bit here. So I'm going to be really bad, and for some of you who've been watching, you may have noticed I've not been setting any constraints. I've not been setting any indexes. So some of the magic that's been happening as well with Aura is they're trying to improve the experience as well. So it tries to guess some of this stuff. So I'm continuing this theme of not setting any constraints on indexes. At some point we will, but for now I'm not going to. So let's take this statement here. So this is quite interesting. And what we're going to do is we are going to take this statement here and let's have a look at what's going on in Aura. So, I accidentally did Control-C and then Control-C again. So let's copy that and pop that in. So let's have a look at what's going on here. So this is the API that we're going to be calling. So, you know, earlier when Alex was going through, Alex, you were talking about, you know, if you've got a data set that you want us to explore and have a look at. So what we're doing here is we've got an open access API. So this is going to request some data, and this we don't need to provide any authentication, which means what we can do is use an APOC function called load JSON. So what we can do here is we could either specify a website that's got a load of, you know, sort of JSON in there, or what we can do as well, we've got here is we can specify a URI which has got a, you know, sort of effectively a link to a REST service, which doesn't require any creds. And we're going to make a call to that to pull back some data. So what we can do very quickly is if I copy this, and let's have a look at what comes back. So I'm going to just 2 seconds whilst I put this, reconstitute this back together again. And obviously this is the other part. So we're concatenating 2 strings. So we're going to be pulling back is a playlist. I don't know whose playlist it is. Exciting. But anyway, so this is, so you can see here. So this
we can all judge somebody's music taste.
Exactly. I think we're bringing back loads of people's playlists, so that's quite exciting. So we've got here a you know, playlist, and so we've sort of got track groups. So this is the parameter that we're passing. So bring back our playlist, and this is all the data that we're getting. So it doesn't always have to be CSVs for us to load. So this is the data that we're looking at. So we can just have a quick peek at what's going on. So I'm really sorry it's not been formatted into that beautiful JSON setup, but we can have a quick look at what we've got. So obviously we've got some data. So there's an about. Obviously there's no information being put in there, but we've got cover. So we've got a link to what the cover looks like. We've got the ID of the person who's created it. A display artist. We've got an ID. We've got a slug, so it describes this as the staff picks. So this is the staff picks playlist for August 2021. There may be some tags associated with that for searching. We've got a title, staff picks, and we've got some information. And here, if we start slipping in, we can see we've got some information about images. We've got some images, you know, different sized images there. We've got the creator ID of this together. So you can see one of these is a test and so forth. So you can see you've got loads of nested information going on in there within our JSON objects there. So we can now, what we can do is let's have a look at this nice bit of code that's going on. So you can see here that Christina's put a comment here in this example, grabbing the listener generated playlist. So that's what we're going to be pulling in here. And what happens is with the APOC procedures, so you always call them. So APOC, for those of you who've not come across it before, is a library of functions and procedures. And the full fat version of APOC has got something like over 400 functions and procedures. And you've got a cut down version of APOC also available with Neo4j Aura. So this allows you to use a lot of these really cool functions. So I'm pretty certain we're going to be using lots of different functions as we go on in this stream. So the one that we're going to be using today is load JSON. So this allows us to pull back these sort of maps, and then we can pull things out. And normally when we use an APOC function, sometimes we want it to bring something back, and we always use this yield terminology. So here we're yielding a value, and that value is going to be the JSON objects. So it's effectively going to take all of this, and when we do yield, it's going to chuck all of that back at us. So then what we need to do is we need to unwind it and then pull different bits out. So that's what's going on there. So we're going to do that. And here we're unwinding data as data. So that's the first sort of key value pair that we've got here is data. I think we've just got the one. Yeah. So I think if I just wrap it in quotes. Yeah, we've just got one, which makes sense because we always have one for the root object. So we're unwinding that to break that open, and then we'll have all of those sort of the sort of array of elements in there afterwards. So unwinding data, and then what we're going to do here, what we're happening. So we know we've got a user object in there. So we know we've got a user and then ID. So I think we saw that a bit earlier, didn't we? We saw a user in here and an ID.
Yeah, we did see creator ID, and we did see user.
And a user ID. Yeah. So you can see there that Christina is basically pulling out the user ID and she's merging that. So that's the equivalent of an upsert. So if you recall what merge does, merge goes off and has a look if this exists. If it exists, then it treats it like a match. If it doesn't exist, it will create it from you. We're doing the same with track group as well. And then we're merging the idea of a user owns a track group. And then within that track group, which is always good practice, is you don't want to put all of the properties when you're doing a merge into your node. What you do is you always merge on the unique identifier, and then afterwards you can set all of those properties. So here, I mean, it doesn't really matter. We're setting whether it's matched or whether it's created. Doesn't really matter for the purposes here. So once we've got that track node, we're then going to be adding the title, the type, the slug, and the track's imported false. So let's load up that data and have a look at what it looks like. So we're skipping slightly the thing about creating a data model this week. So it's slightly different. So what we will do when we come back to this data set is we'll explore the APIs and see what data is, and then we will come back on that and then create the data model. But for now, we're going to take the fact that Christina's done all of that hard work for us. We're going to create some data. We're then going to look at the data model, and then we'll think about what questions we might ask. So we're a little bit topsy-turvy this week, but it's a fun data set, and we're using a brand new way of being able to pull the data. So we hopefully you're going to let us off this time. And what we're going to do next time, so if you've not, I'm going to do a cheeky little plug as well, is that my other colleague Will and I've got a podcast series that we started, Graph Stuff, and our recent episode that's going to be coming out soon, we talk about all the different places you can find data sets. So if you can't think of creating a data set, we talk about all these different and cool places you can find data sets, including lots of these open sort of APIs that you can pull data from. So if you want to go and have a look and suggest some data sets, then please do. So what have we got that's popped up is Tamaj says you can also handle API key authorization, absolutely, and other post requests with APOC. So basically, when you have you can have the parameterized key authorization, that kind of thing. Yeah, you can also bring those in as well. So if you've got any of those data sets or APIs you want us to play with, then do suggest them and we'll have a look. So we've put that in, so let's have a look at so far. So what we know is we're going to have a user and a track recommendation, so we can do that. So we can call db.visualization, And we're going to see that. So we know that that's nothing, nothing to surprise us so far. So let's see what else Christina does. So we're going to add some more track groups. So again, I'm just going to take these and copy them. So what we're going to do here is, we're just adding more. So what we're doing here is we are calling track groups. Okay, so let's do that, and then we can have a look at what that sample data looks like too. Oh, I did that again. And so we're taking off the playlist bit. So what's happening here is that obviously you're going to have more track groups than you're going to have track groups on the playlists. So what's happening here is we're just now pulling back all of the track groups, because obviously they're not all going to be mentioned in playlists, but we're interested in having a look at playlists. And eventually what happens is we start taking music genre tags, and so that's why we need the playlist, so we can start to think about if we're making recommendations and what kind of music people might want to look at. So good fun. So we've loaded in some more data from that. I'm just going to close this so I don't accidentally keep pressing the wrong buttons. And then what we've got here, we're then going to add some tracks. So you've got the track groups, which I believe are groups to albums. I could be wrong, I'll have to double check that. But then we're now going to add tracks to those track groups, and let's bring that in. And we've got another APOC procedure in use as well, which is exciting. So we'll talk about this one quickly. So this is one of my favorite APOC functions, which is the periodic commit. And so what this does, so sometimes you can't always load all of you can't always execute this one big block of Cypher script that you want to do straight away. So sometimes you need to break up in a certain way. So what happens with Cypher when you're running queries is if you've got like a load of things going on, like you've got loads of merges, or you're pulling in like a big data set or something like that, and you're doing some manipulation or work with it, Cypher will try to bring everything into memory and then executes it whilst it's all, does all these functions whilst it's all in memory. Now, for situations, so for example, with Aura free, the amount of memory is not a huge amount, or you're working with someone, like you don't want to go off and get like a machine with massive amounts of memory, when actually you can be a bit clever with how you structure your query. And many times we don't necessarily need to have everything in memory and process it all at the same time. So what we can do sometimes is just chunk it up. And what APOC periodic commit allows us to do is it allows us to chunk it up. And how we do the chunking up of our data, or the chunking up of the process that we're running, or the query that we're running, is using limits. And it doesn't have to be limit. You've got lots of other ways of doing it, but just an example here, we're doing it with limit. And obviously, as you know, this is going to limit the number of nodes or lines or things that we're pulling in. And then we effectively call the periodic commits. In the first part, we give it our Cypher query. And then in the other bit, the other parameter, we put in the value for that limit. So here we're putting in the value of 10. And then how the APOC periodic commit knows that that it's finished, it doesn't have to keep going, is you always have to return a count of something. And if you think about what happens when we do this kind of query, it's going to do a match, and at some point there's going to be a situation where everything's been done. So here where tracks imported, so you remember we said that Christina had that flag earlier where tracks imported was false, so she's setting them as true, going for all of them. And at some point it's going to happen where we're going to do a match, and this is going to be, all of this is going to be none, there's 0, and then this is going to eventually return a count of 0, and then it knows, the procedure knows that it's finished, everything has been done, it has been concluded. So that's that. And there's lots of fun ways that you can use APOC periodic commit. So for example, you can use it for iterating. So if you're doing like your sort of homebrew graph algorithm or something like that, you can use it just to keep iterating over. In fact, I think for the Summer of Nodes last year, I used periodic commit to do the table sorting. When we're trying to put guests to tables, you can do that as an example. So there's lots of really fun ways you can use it. So there we go. Run that. We've pulled in the tracks, and then we're going to load in some tags as well. So let's do that too. So we'll do this one, and then we'll have another look at our data model and see how it's growing out. So we've got our users, we had the track groups, we've added some more track groups, we've now added tracks to those track groups. We're now going to be adding some tags. So let's continue putting some more data. Oh, we just got an error. Let's just quickly see what's the problem here.
I think you didn't start at the top by copying it over.
Oh, did I miss some stuff? Hang on, let's get rid of that just in case. Oh, yes. Oh, yes. Well spotted. Well spotted indeed. Very excited to have a play with this data, I have to say. Right, so that's all put in there. So let's quickly remind ourselves what our data model looks like. So look, there we go. Look at this. So we have extended it. So we have got our user. A user creates track. The user owns a track group. The track group has a tag. And what have we got here? So we are doing that. Okay, so this is all connecting to the database. So that's fine. So we have loaded our data. So this is our data in here. And we have got, so we said, like I said, we've got the user. User owns a track group. Track has some tags. It's created. So what we're going to do quickly is let's have a look at some stats of our data. So how many we've got of each category. And then I'm going to bring back some sample data. And then it's going to be over to all of you to suggest what questions you want with this data. So let's quickly do match n, return n, labels. This is one of my favorite queries. I just like, well, when I spell it correctly, it's one of my favorite. Labels n, count, start. And I just love this because it just tells me like a view of what have I got in my database, what data. And what's interesting here is we've got a load of nodes that don't have a label on them. So I'm going to have to be nosy and have a look at what those are as well. But you can see what we've got. So we've got 148 users, we've got 126 track groups, we've got 103 tracks. I suspect this is going to be related to the tracks. We've got the same numbers and we've got 28 tags. So let's quickly have a look at those ones where it doesn't have a label. So let's do where labels n is equal to, I think it's going to be something like this, isn't it? And return star. So let's have a look at those ones that don't have a label. Oh no. Where not. Oh, where not exists. I can't think of, I'm going to have to try and figure out how I'll have a little think about that to see this, to figure out how to pull out those notes. I can't remember off the top of my head the query. Oh, so Ark's joining us on YouTube and he's new to coding. So that's exciting. Welcome for joining us. I'm in the US and it's 3:30 in the morning. Oh my goodness.
It's early. Yeah.
Well, thank you for joining us, Ark. So yeah, please keep chipping away at the coding. And if you're completely brand new to Neo4j, do keep an eye on notes. Like we've got Graph Academy, we've got a bunch of stuff that you can have a look at to help you get started. So thank you for joining us.
Exactly. I'll pop the link out for you for the Graph Academy, which is a perfect way to start.
Yeah, absolutely, absolutely. Okay, so let's have a look at some of these tags. And in the back of my head, I'm going to be figuring out how we're going to pull up those nodes that don't have labels. So I'm just going to quickly take this. And I think they've all got name values on them. So let me just have a quick peek. Yes, they've all got names. So let's bring back what tags we've got. I'm very excited. And so let's do return n dot name. And we're going to order them by name. So let's look at what tags we've got. Alternative, ambient, techno spelled a different way. Oh, that could be another, that could be a question jumping in my head. Dark ambient, dark wave, down tempo, dream pop, Jerome electro pop, electronica. So this is interesting because straight away it's jumping in my head. I think some of these are going to be very similar, but I think some of these tags are the same. They've just been spelt in a different way. So that might be an interesting question that might pop up. So those are some tags. And let's have a quick look at what other data we've got in here. So let's have a look at, so I think our user, we're just going to have an ID on there, aren't we? So, oh, look at this. N1's already coming in with the first questions. Most popular artist by tag. I love it. We have got, let's have a quick look at what kind of data we've got in tracks. So in tracks, if I just click on here, we have got just import. Oh, we've got title. That's probably not, that was a terrible one to completely click on. So that was completely by accident. Not the most appropriate title for this time of day. That's all right, it's all good. So you've got some titles here. So we've got title, so not completely here. So that's the, that sounds like my start to the morning. That was a very, very good track title. Okay, so in tracks, we've got track title. Then what have we got in track group? Let's have a quick peek. So we've obviously, when we had a quick peek at the data, we saw we had things like the slug. So obviously that would be, it tends to be the title we have on the page. So we've got ambient evening music. That sounds like something I should be listening to later on today. Obviously you've got type playlist. Okay, so you've got some interesting information there. So anyone's shot straight in there and suggested what's the most popular artist by tag. So over to you, Alex. Have you got any thoughts about what kinds of questions you'd like to ask?
Can we find out which artist is in the most playlist represented?
Ooh, so we've got what's the most popular artist by tag?
Or which song rather? Maybe the song is easier. Which song is in more than one playlist, and which maybe like a popular song that is in many playlists.
So what song is in more than one playlist? I love that. And then what's the most popular song? What's in playlists?
Yeah, that could be good.
Ark has suggested how often do we hold these casts?
Exactly. Yeah.
So the good news, Ark, is we do them every week. Slightly bad news for you, Ark, is that they would be at 3 a.m. local time. We follow up with some more good news, is that the recording is available immediately afterwards on YouTube. We have got playlists which is Discover Aura free, so you don't have to watch them all live. We do put the recording, and we do have a GitHub repo as well where we also write out what we've done in the code. So if you don't fancy joining us every week at 3 a.m, then
yeah, exactly.
Yes, Samit, please do join us. So yes, we are here every week at 8 a.m. UTC. So we are here every week on Monday at 8 a.m. UTC. So yes, please do come and join us. If you've got suggestions for the notes, then please come in. So Mike has just asked about the Api plugin. Yes, it is available on Neo4j Aura. It is the cut down version. So not all of the functions that are in APOC are available in Aura, but we do have it on. And what you see now on the screen, this is Neo4j Aura free in use. And you can see the APOC functions that I'm using here. So yes, it is available. Okay, so do we have any more questions for the data? Questions in general are good as well, but questions for the data. So do we have any questions we want to ask? I mean, one I'm quite curious.
Yeah, exactly. What is your?
I've got a couple. I've got two. So one of them is, I want to know how many similar named tags have we got? Because I noticed a few of them looked a bit similar. And actually, I think we're going to use another APOC function for that. So I want to know how many tags are similar. Tags are similar. And similar is a very subjective term, but how many tags are similar in our data? And the other one that I was quite interested with as well is finding about which tags commonly appear with other tags. So things like, because if we go back to our data model, let me just scroll back down again. We have got this. Obviously, we've got track group, and then a track group as a tag, and that track group is going to have more than one tag. And what I'm quite keen to know is, are there groups of tags that commonly appear together? So like ambient and ambient techno, for example, are there like common groups of tags that always appear together? So we can roughly query for that, quickly. So do groups of tags appear together frequently? Okay, so I think we've got a good set of questions here. So I'm just going to take a cheeky sip of my coffee, which my colleague Alistair, the original creator of the Arrows app, snuck into the room for me. So
Oh, that's nice.
I know, it's very nice of him, wasn't it?
Yeah.
Right, so the questions we've got lined up, we have got what's the most popular artist by tag? We've got what song is in more than one playlist, and then a continuation of the question, which is the most popular song in the playlist. And then we've got how many of the tags have got similar names, and what groups of tags appear together frequently. And oh my goodness, that there is some dedication from Mark. So 3M is doable, and you've been practicing coding, so well done you. And congratulations to Sumit as well, being a certified developer. So for those of you who are loving Neo4j, we do have a completely free certification program. And for those of you who are more, I don't know whether to do it, whether or not, it's well worth it. And you also get a t-shirt. The t-shirts are back. Definitely worth doing. Right, so let's get to it. Let's answer some of these questions. So we've got the first one, the most popular artist by tag. So we have a quick peek here, what's going on. And let me just make this a little bit more readable. So I'm just going to click on our user. And if I select a name, just so we can see these. So in track group, we can see this is track group. Ooh, oh, this is exciting. Oh, there it is, name. So you can see here, so we have got a user, track group, I created track. So let's just check to see. So what's the most popular artist by tag? So we can't do the artist, but we can do the tracks. What's the most popular track by tag? So we're going to do that. Oh no, so track group presumably is the same artist. I think you looked, you saw that, didn't you, Alex? Sorry. Oh,
what do you mean?
Because you said what's the most popular track by artist. So in the track group, we've got.
No, I mean, no, well, yeah, I thought maybe if a track is in a playlist, we can say if it is in more than one playlist, and then by that refer that it is a popular track. I don't think we have artists as a separate node, but we have the track name, so we can say.
Indeed. Yeah. No, I was just checking that. So I wrote that down wrong. So if I go back to the data model here, yeah. So what we can do is a track group is effectively our playlist, and track is obviously the track. So what we're going to do now is find out those popular tracks in the track group. So what we're going to do, we are going to do match T track, and obviously we need to go into this. So we can do created. Yeah, so I just need to double check this, our user, but that's fine. For the purposes of this, it's all good. Let's go to owns. Oh, I got to go into node, can't go relationship, so that's going to be our user. I'm not worried about our user. And then we do owns. Then we're going to do track group. So if we then return now T, I'm really scared to do t.title in case there's some really offensive title names in there. I'm scared. So what did we say? We said it was track is title, isn't it? Yeah, t.title. And then I think if we do so do you want to do this by user, or do you want to do this by playlist? Do you want to do it by playlist, don't you?
I would do it by playlist, yeah.
Okay, so if we do so, because a user could have more than one playlist with that song appearing on there.
Yeah.
Freck. And order by Freck descending, and then we said more than. So I'm going to kill two birds with one stone, or as a colleague says, feed two birds with one stone, which is much nicer. No birds died in that. You just fed them. And if we say, because you wanted to know songs that appear in more than one playlist, so what we can do here is we can say, I think we can do it in here. If not, we can put in a where clause. So where Freck is greater than one. So we're saying it has to be more than one song. So hopefully it's all, no. So I need to just do this. I'll do it like this. Let's do with t.title count tg at Freck, where Freck is greater than one, and then we can do do this. This will definitely work, and I'll make this a bit more efficient later. Oh, hello. Yeah, I know I did wrong here. Title, and then what we do is return this as title. This we're returning as frac because we've already done this, and then this will. There we go. Right. So there you go. So
cool.
So we have got. Let me just quickly expand this. There we go. So there we go. So we've made sure that we're only pulling back the songs where there is more than where it appears more than once in a playlist. That answered the first one, which was which song is on more than one playlist. We can see the most popular song here, the most popular song on the playlists that we've imported is Into the Mist. So that's the first question answered. So let's move on to the next question. So the next question was, what's the most... Oh, yes, that was a question that anyone asked. So we've done that one, and we've answered your one as well. Alex, I think you did another one, which was... Oh, no, we've done those. So that was the most popular... Oh,
that
no,
the song by playlist, but we didn't look into
do
the
by
tag.
title. Right, so sorry, anyone, we're going to do yours now, which is... So we haven't got artists, but we can do it by track. So what we're going to do is we're going to look at the most popular song by... it's popular track by tag.
But yeah, that should work. Yeah.
Yeah, so let's have a look at let's quickly refer back to our data model. So we've got track, so we've got track groups. What we need to do is add the tag. So I'm just going to copy and paste this up here. Oh, I'm going to make a copy of this query as well, actually, so that I remember to write it up later. Save myself a bit of time. And then let's have a look. And I'm just going to close this. Just close these for now. I'm going to probably regret doing that. That's all right. Remember it was name. So it's just go back up to our data model. So let's do, we want to know by tag. So let's bring in tag as well. As tag. 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 And then what we're going to do is, what's the most popular, what's it asking? Most popular track by... Oh, how are we going to do this?
The question is that the track group has a tag, but not the track.
Yeah. So no. So I'm just trying to think, because obviously we can't do... So what perhaps we want to say is what's the most popular tag is probably what we're trying to answer the question here.
Yeah, I think that's what we want to answer, yeah.
So what we're going to do is we're going to switch this out, and we're going to say... So we want to do tag.name as tag, why not? Actually, I don't want to do... Let's do this. With tag.name count track as frequency. We can do all of them, that's fine. And then we're going to return tag.name frequency, ordered by frequency. So that will tell us what's the most popular tag to music, which I believe that's the question you were asking. Anyone? If I'm not answering your question correctly, let me know. I'll correct it. So, oh, I've done that thing again, haven't I? So what if I not alias correctly? So, okay, right. So the most popular tag being used is electronica. I like me a bit of electronica. It's all good. And I suspect as well what's going on here is there will probably be quite a few tracks that have got the electronica tag as well as the ambient tag.
Mm-hmm.
So what we could do as well is if we go back to our popular song, we can have a look at what tags we've got. Actually, we can do that we can grab the songs and see which songs have got the most tags. We'll do that one afterwards, but I think that's fun as well. I think there's loads. I think we're coming back to this data set, so don't panic, everybody. I think there's a lot of mileage we can get out of this data set. But let's go back to, because we've got 11 minutes left, so we might even be able to sneak in an extra question. So if any of you have got an extra question you want to ask, pop it into the chat.
Exactly.
So let's look at the next question, which was how many tags are similar? So I'm going to put this, how many tags are similar? So if you remember, if we go back to our, I'm going to just cheat and recycle this one. So we go back to our tags. go back to this one. If you remember, we had some of these like ambient techno and then ambient techno. So we've got an extra T there, but they're treated as different tags. And then we've got things like electronic,
electronic pop, electronic. That's also similar-ish.
Or they may be the same. So we've got a couple of those going in there. So what we can do is I'm going to show you another APOC function where we can do some fuzzy matching. So within the APOC library, you've got a load of fuzzy matching options. So let me just bring back, so APOC text. Yeah, let me just bring back the docs. I just want to pull the text function page. So this is great fun. Let me just nip over here. So we have got a load of text functions available in APOC. So I will pop the link into the chat for you all, so you can have lots of really useful things in here. And you see all these text things, you've got some text extraction, but the ones that we're going to have a play with now are the text similarity functions. So for those of you, perhaps, so you may have come across things like Levenstein distance, Levenstein similarity. So you've got all of these nice things that we can use to compare the similarity with. And the one I use is, I quite like using Sorensen dissimilarity as an example. So the thing you have to bear in mind of all of the different similarity functions is obviously there is each one does things a different way. So Levenstein similarity will do things like, or Levenstein distance will do things like saying how similar are two words based on, how often characters flip between them, but it's quite subjective. So obviously two short words are, may score quite well, whereas you can have two very long words where just like, if somebody's missed a letter or something and the score is going to be quite bad. So you just have to be bearing in mind the different text fuzzy options. Arc, no problem at all. You are completely new to this, so don't panic, you're learning. We're all learning. We are all learning. So let's have a look. So I quite like using the Sorensen dissimilarity. I'm not going to talk about the formula that's being used, but what I like about it is that it gives me a handy score out of 100 to tell me how similar two words are. And it's quite nice if you've got longish words. So I'm going to be using that one. And I believe that it's a function. So what we can do is just jump back. So what I'm going to be doing is I'm going to be getting the tags. I'm going to do T1 tag. So what I'm going to do is I'm going to pull back all of the tags. So we've got 28 tags. And I'm going to be doing two tags. I'm going to be comparing those two tags, and I'm just going to be bringing back the similarity. So hopefully this will make sense. And those of you who may have seen me with my text comparison stuff, this will be very familiar because I do this all the time. So where T1 is greater than T2, I just do this.
So this is basically just looking into how the two tag names are called. We're not looking into, let's say, two playlists that have tags and then comparing because of overlapping tracks. Then this would be the more involved thing. But at the moment we're just looking, is tag 1 similarly sounding or written than tag 2, and then compare the two.
Exactly, that's exactly what we're doing. So what we're doing is we're basically pulling back all of the tags. So we're not looking, this is not a graphic query at all. We could then further extend this to make a graphic query where what we can say is, well, okay, so these two tags, we've identified that these two tags string names are similar. So what does this mean for the songs? Do we now need to have to recompute all of the songs that we've, before we said see which was the most popular tag and that kind of thing? Maybe what we can do as well is when we've done a bit of cleaning, we can start to associate tags and go, well, does ambient only ever happen with like electronica or something like that? So there's lots of different things where we can apply that. So let's do this. So and what I'm doing here, this where clause here is just making sure that I don't compare the tag against itself, and I'm cutting down so that we don't do the reciprocal tag comparison. And what I'm doing, this ID just basically refers to the internal ID of the node. So every node and relationship in the database has its own internal ID, and this is just what I'm using to check against that. So what we're going to do here is we're going to do return apoc.text.sorensen by similarity, and we're going to do t1.name, t2.name, as score, order by score descending. And obviously we want to know what we're looking at. So we're going to do t1.name, t2.name. So what we're going to do here is we're going to bring the name for the two tags, so tag 1 name, tag 2 name. We're then going to do the, basically we're going to, using Sorensen dissimilarities, to compare how similar those names are as the score. And we're going to do the ones that are most similar to the least similar. So let's have a look at what comes back. Ooh,
I think you miss a D at the line 3 ID 2. Could that be?
Yep, and I also put an extra comma. So ID, yes, you are right. That should be ID. Okay, right, we are in business. So look at that. So you can see this is just us having a bit of fun, where we can see that ambient techno and ambient techno with an extra T are very similar. So they've got a score of about 96% similarity. And you can see electronic and electronica, we got the extra letter, they're about 95% similar. Yeah, so this is where you have to start being a little bit careful. And there is a whole conversation about being aware of what your tool does, because all of a sudden you've got neoclassical and classical, and they say, well, they're 82% similar. But yes, when you sort of, obviously you've got those extra few words, but obviously neoclassical and classical are going to be two different genres. Neoclassical are going to be newer classical music. Classical, we're probably talking about, like sort of Mozart and Schubert and that kind of thing. So, and then obviously you start to get the idea of electro-electronic, electro-electronica. You can start to see, and as you go down the list, they're becoming less and less similar. And then hopefully you've got a really one where we do as an example, they're not similar at all. So there you go. So it turns out, and this is where it starts to get really interesting. And this is where we need to start using graphy data.
Mm-hmm.
So this is definitely going to be for a next episode. So you can see here that electro-pop and dark ambient, like as far as strings compared, they are not similar at all. They've got a score of 0. They are completely different. But from a genre perspective, you can easily have dark ambient electro-pop music. You could easily have ambient electro-pop music. You can have house, which, some people may think it, has elements of electro-pop. So this is where it starts to get quite interesting, in that whilst obviously when we're comparing them just as the elements on their own, yes, they're not similar, because this is it, we're comparing strings. The strings are not similar. Yes, absolutely, score of 0. This is when we start taking a step back, and if we want to start having a look at, well, what tags associate with other tags, if we want to start making recommendations around music or discovering new genre, that kind of thing. This is when we want to start using graphy structures. So maybe we're going to start using graphy structures of songs or playlists being compared to those tags. Then we start to say that whilst as a string, electro-pop and dark ambient are not the same, they probably feature a lot together in certain songs. Does that make sense? I hope it makes sense.
That does make completely sense. Yeah, that's what I meant earlier when I said, okay, we look at the names of the tags and comparing them. But this is the perfect example, like you said, electro-pop and house is definitely not a 0 score. They are much more similarities than there are not. So if you were to say techno and classic, yes, of course, that is a 0 overlap. So they're completely different worlds. But and they would probably also count a very low score here, because techno and classical is written differently, obviously. But yeah, like you said, I think if we look into the playlists, what playlists have what tag and what songs are part of what playlist, and I would assume that a playlist with an electropop tag and a playlist with a house tag probably will have some songs, both, but a playlist with the tag classical and a playlist with the tag techno definitely will not have the same song.
Oh, they might.
No.
Neoclassical, they might.
Neoclassical, they might.
That's a whole different ballgame. Let's not go down that path. But yeah, no, absolutely. So Ark's just asked a quick question about GraphQL. Is GraphQL rated more towards data science, or software engineering. So is that I'm learning both. So curious which is most tied to both. So probably outside the scope of this conversation, but I think you tend to see think of GraphQL as a way of being able to retrieve your data. So it's quite possible you'll definitely see them in software engineering, and I don't see why you wouldn't see GraphQL being used in data science for the purposes of retrieving data. So hopefully that helps. A little bit out of the scope of this, but hopefully that will help you. No, you do not need a solid background of Python or Ruby or JavaScript to do this. You are perfectly capable of learning about graph databases and querying them without necessarily having to worry about a programming language. So all of this stuff that we're doing now, we're not touching any language, any programming languages. We're just using Cypher. So you are in good company here to be able to learn this. Okay, so we had one more question. We are to time. So let's quickly sneak in the last question and then we are done for another week. So one more question, which was, do groups tags appear together frequently? So let's go back to the data model. So I'm going to just do a quick, so this is going to be like a partial query to answer this question. I'll just quickly make sure I've got a copy of this query before, I've already got a copy of it. So let's bring back the schema again to just remind ourselves what it looks like. So what I want to know is how often so we're going to have to do this via the track group. So what we want to see is do tags gather together with the track group. So what we're going to do, I'll do, based on the track group, do we have tags that commonly appear together? So we're going to do a quick and dirty example of this. And what we're going to do is let's just do track group to tag. And let's do match track group. Sorry about that. I think that's the fire alarm practice. So let's do track group has tag and what we're going to do is just return. Let's just return some tags. I can't remember what we had for tag group. What's it? There'll be nice ways to do this. So when we come back to this, we'll have a look at the nice ways of doing this. So I think track group has an ID. It has an internal ID. Oh, it's got a UUID. Let's just stick with UUID. So, we can go with the slug. Let's go with the slug. Return slug. And let's return let's just bring some of these back just so you can know this. You can start to see groups, and then the next extension to this query would be to try and start to bring together tags that are commonly appearing. And what you can see very quickly, you can see where we're starting to have this problem with the names. You can see, look, you've got ambient techno, house, ambient, experimental, electronica. So you can see straight away, but by us doing a bit of cleaning on some of the strings, we're probably going to clap some of these down together. So yeah. So we've answered most of the questions. I'm going to try and expand on this one a little bit more in the write-up of the GitHub repo. So we'll cover those. But otherwise, I think we're done for a day. I think we've answered all the questions.
Looks like, yes.
More or less.
Yeah. Every question is answered. Ark will be a graph expert by next week, he promised. So
fantastic.
Looking forward to it.
Think about that certified Neo4j professional.
Exactly.
Shiny T-shirt with a brand new logo.
That will be good. Yeah, we will post it on GitHub, so you can follow along afterwards. The video will be available on YouTube as usual. There's a playlist, so if you watch us for the first time today, check out our Twitch playlist on YouTube, and then you can watch the previous episodes. Yeah, and I think I'm looking forward to next Monday. We have a couple of other sessions. I think Will is on this Thursday, so if you're interested in GraphQL, Will is having his session this Thursday. We're back on Monday. Yeah.
Yes, and if you've got any data sets, so if you've got some CSVs or some open like sort of REST APIs or something, ping us. So either drop some, sort of put it in as put it as an issue on that GitHub repo, or either sort of tweet me or Alex on Twitter with your suggestions. If you've got it now, quick chuck it in the chat if you happen to be ready. But yeah, let us know, because we are totally up for exploring any data sets that you have. So let us know and we'll do it.
Exactly. Take care. See you soon.
Have a lovely day all. Bye.
Bye.